In this section, we'll talk about operations on real numbers. We'll start with operation on real numbers. Then we'll talk about identity relating to a square root. And at the end, we'll take a look of some example. What is operations on real numbers? Rational numbers are closed with respect to addition, subtraction, multiplication, and division. Rational numbers are closed. What it means to you? If we try to add, subtract, multiply, or divide, except 0, any two rational numbers, then what you get is rational number. Irrational numbers, however, are not closed with respect to addition, subtraction, multiplication, and division. What it means to you is when you try to add, subtract, multiply, or divide, except 0, any two irrational numbers, then you may get irrational number or rational number depending upon the output of the operation. So remember, rational numbers are always closed. What it means, if you do addition, subtraction, multiplication, and division of two rational numbers, you always get rational number. However, irrational numbers are not closed with respect to addition, subtraction, multiplication, and division. Let's take some example. If you try to add square root of 6 and minus square root of 6, what you get is 0, which is rational number. And same when you try to subtract square root of 2 with square root of 2, what you get is 0, which is also rational number. If you multiply square root of 3 to square root of 3, what you get is 3, which is rational number. If you divide a square root of 17 by square root of 17, what you get 1, and that is rational number. So these are some examples where you had two irrational numbers which you were trying to either add, subtract, multiply, or divide, and your output was rational number. There are other examples where you can have two irrational numbers. Example is square root of 2 plus square root of 3 gives you irrational number. Square root of 2 multiplied by square root of 3 gives you irrational number as well. And when you try to divide a square root of 3 with square root of 5, you also get irrational number. And same, when you try to subtract a square root of 3 with pi, you also get irrational number. So these are some examples where you had two irrational numbers, you were trying to add, multiply, subtract, or divide, and the output was irrational number. So let's try to understand in terms of output on different numbers compared to operations which we can perform. So if you have a rational number and another rational number, and if you try to add them or subtract them or multiply them or divide them except 0, what you get as an output is rational number. And here are some examples. 2 by 5 plus 3 by 10 will give you rational number. 2 minus 5 will give you rational number. 9 multiplied by 5 give you rational number. And 3 by 5 also gives you rational number. However, if you try two irrational number and if you try to add them, subtract them, multiply them, or divide them except 0, what you get is rational number or sometimes irrational number. So there is no guarantee what you'll get. You may get rational number, you may get irrational number. An example of you getting rational number is when you divide a square root of 17 by square root of 17, you get 1, and that is rational number. However, when you try to subtract a square root of 3 with pi, what you get is irrational number. A subset of the same context, if you have a rational number and another irrational number, and if you try to add or subtract, what you always get is irrational number. Example is 2 plus the square root of 3 and 2 minus the square root of 3. When you try rational number and irrational number, and if you try to multiply them or divide them, you again get irrational number. An example is 2 multiplied by a square root of 3 will return you irrational number. So no matter whether whenever you use irrational number with rational number and you try to plus, minus, multiply and divide, your output is always going to be irrational number. Now let's talk about identity relating to a square root. Most of we know x plus y multiplied by x minus y is x square minus y square for any real number x and y. Now let's look identity related to a square root and see. And to see this, let's assume a and b be positive real numbers. Then what happens? First, if you have a square root of a multiplied by b, you can represent them as a square root of a multiplied by a square root of b. If you have square root of a by b, you can represent them as a square root of a divided by a square root of b. And if you have a square root of a plus a square root of b, and you multiply this by square root of a minus a square root of b, what you get is a minus b, because of x plus y multiplied by x minus y will give you x square minus y square. Now similarly, when you have a plus a square root of b multiplied to a minus a square root of b, what you get is a square minus b. Now when you try to multiply a square root of a plus a square root of b to a square root of c plus a square root of d, what you get is a square root of ac plus a square root of ad plus a square root of bc plus a square root of bd. And last, when you try to do a square root of a plus a square root of b whole square, what you get is a plus 2 square root of ab plus b. Now let's talk about some example. If I have to add 2 square root of 2 plus 5 square root of 3 and 2 minus 3 square root of 3, how can we add them? In order to add these two numbers, I'm going to combine a square root of 2 together and a square root of 3 together. So I can break them as 2 square root of 2 plus square root of 2 plus 5 square root of 3 and minus 3 square root of 3. Now I can take square root of 2 out, which gives me 2 plus 1 multiplied by square root of 2. And I can take a square root of 3 out, which gives me 5 minus 3 square root of 3, which in turn give you 3 square root of 2 plus 2 square root of 3. Now if you try to multiply 6 square root of 5 by 2 square root of 5, what do you get? Again, you can combine them, arrange them in a way where 6 square root of 5 multiplied by 2 square root of 5 can be represented as 6 multiplied by 2 into square root of 5 multiplied by square root of 5, which in turn will give you 5, and 6 multiplied by 2 will give you 12. So 12 multiplied by 5 gives you 16. Now when you try to divide 8 square root of 15 by 2 square root of 3, you can break them again. 15 is nothing but 3 into 5. So I can represent 8 square root of 5 as 8 square root of 3 multiplied by square root of 5. And I can divide it by 2 square root of 3, where these 3 can cancel out. and what I get, and this 2 can cancel this 8 with 4, so what I get is 4 square root of 5. Thanks for watching. You can visit us on www.classisfun.com.